going through these controls, the thing is you're going to have to take the time and go through the controls either outside of work or in work. But if you could do more outside the hours and the minutes you put in outside of work, it's just going to help you when you're on the job. When I first started out, there was just so much trying to learn. And then when I got into those controls, I really had to take some extra courses for me to really understand those. I could not just jump in and learn it and then go to the next one and I'm on a Danfoss controller or anything like that. You have to take the time and invest in yourself to do it, because then when you go on those service calls, you're going to rock it.
Welcome. So glad that you're here coming to hang out with us. We're here chatting, me and Andrew Freeberg. Today we're going to be diving into becoming a better technician with electronics. But first of all, Andrew, why don't you introduce yourself for everyone?
Hey, everyone. Glad you guys are here. My name's Andrew Freeberg. I work at RUI, just a supermarket refrigeration shop, and been doing this for about 16 years and loving every minute of it. It's just one of the best industries that we could be in.
Totally agree. And there's so much always on the go. Like we're doing tons of free sessions all the time, but we thought that we come and have a conversation about becoming a better technician with electronics. And the big thing is that get a better understanding of the electronics, what you're working with, because we know today that there are tons and tons of different uh, controllers out there, different electronic controllers, different electronic systems. And it's important to take the time to understand each of them. This doesn't happen overnight, but you can start to learn them over time. And the first thing is to do is to find out what controllers that you even have in your area. Andrew, do you kind of have an idea? Because you do a lot of supermarket work, you do a lot of service on CO2 systems and supermarket systems. You crush it all the time. But in your area, you have a lot of consistency, I'm sure. You don't have all 50 or 60 different controllers that are out there for refrigeration systems. You have usually a few main ones, and then you'll maybe have the one off somewhere else. What are some of the controllers you're seeing out there, Andrew, on supermarket?
Yeah, the biggest one is the Einstein 2, and then the Danfoss. I don't know the model number, but
Yeah.
and the Danfoss, and it could be either the buttons down below or the touch screen. I do come across the RMCC
Yeah.
controller. Yeah, the kind of older one there, and then microthermal. So
Yeah.
I tap into a little bit of mixture of everything. So my exposure to all electronics is kind of crazy.
Yeah. And the big thing is just like Andrew and me, it's you don't learn these overnight. And I hear lots of people, I'm no good with controllers. I'm not good at controllers. If you keep telling yourself that you're not going to be good with controllers, you're right. What you tell yourself and keep telling yourself, that's what it's going to lead to. But if you say, okay, I got all these different controllers, but I want to learn them, you're going to start to learn them. And you can, because the information is out there, but it's you that needs to spend the time on it. And you can't just do this during your work hours. We all would love to, but there's too much out there. Just like Andrew just said, E2, microthermal, Danfoss. That's three controller platforms. They're very big. There's many more out there. Um, inside the world of supermarket refrigeration and diving into them, like you need to get a good handle on which ones that you're going to work at on in your fleet, because some people I know, they work on Krell, Danfoss, Nova, microthermal, and E2, and this is difficult. This is overwhelming when you have that many different controllers. And I'll show you a couple of screenshots of a few. So if you take a look here, for those that are watching, we have a couple that you may recognize on there, and take a minute and take a look at them and see if you know some of these controllers. Okay. And if you want to throw it in the chat for those that are on this free webinar, throw it in the chat to see if you know which ones you know on there. Because this is important. By looking at them, will give you a better idea of what you're working with. Because I know I walked into systems before, looked at the controller, I didn't have a clue what they were. And this is something that you need to understand. So we can see up in the top middle, there's a Danfoss controller. We got microthermal, we got RDM, you got Corel, E3, Dixel, you got Worm as well. They're from a Germany. You may have never seen that before, but I thought I'd put that up there because depending on where you're at the world, you may see these different controllers, and there's a lot more out there. I don't even have them all on here. But the thing is that you want to spend the time to get to understanding, and I think it starts with, for me, is understanding the basics of refrigeration. What do you think about that, Andrew?
Yeah, going through these controls, the thing is you're going to have to take the time and go through the controls either outside of work or in work. But if you could do more outside the hours and the minutes you put in outside of work, it's just going to help you when you're on the job. For me, when I first started out, there was just so much trying to learn. And then when I got into those controls, I really had to take some extra courses for me to really understand those. I could not just jump in and learn it and then go to the next one and I'm on a Danfoss controller or anything like that. Really, you have to take the time and invest in yourself to do it, because then when you go on those service calls, you're going to rock it.
Yeah, I totally agree. Because I know I've walked up to stores before and then didn't even know how to log in. You know what I mean? Like your first time out there at the store, it's like, what? How do I even log into this controller? So step one is getting that basic understanding, because this could happen to you. That login, excuse me, that username and password, you may not know it. And what I keep teaching more and more people is you should have your own user name and password. So you log anything you do on that controller, it's logged, because it's so important to understand what you did. I really didn't like, especially on the E2, just user and pass. You know what I mean? Anyone could go in and change anything. You don't know who's messing around with it. And I've seen it many, many times where people would say, "Oh, that wasn't me. You know, I didn't change anything." But you wouldn't know. And it doesn't matter if you, for me, it didn't matter if you changed something and if you made a mistake. That happens. This is refrigeration. We do make mistakes. But it takes us a lot longer to figure out a problem if we don't know what's been changed. What are your thoughts on that, Andrew?
Yeah, going in and messing with set points and losing what you're doing could really take a rack out if you do something major like that. So definitely take note on what you're doing. A lot of the controllers now, we're kind of getting locked out, so you can only do the basic stuffs too. But there is still a ton of stuff that we can go out there and work on everything. We could change condenser set points and SSTs. I mean, it is dangerous if you don't know what you're doing.
I totally agree. And the big thing is on some of the newer controllers, everything is logged anyway. So even if you go and change something,
Right.
you use user pass, you can go back in, even in the E2, you could go into the master log and see what was changed at what time. And so you could go back and figure out who was there between those hours. It takes a technician a little bit to figure this out, but you can even do it on the E2. I know how to go into the deep logs. And so the E3 is super easy to do, because the E3 a few weeks ago I was at a site for a startup and we were going through it step by step. And the experts from Copeland were showing me that here's the log. Like anybody change, any change that's made is logged. The time's logged. There's a timestamp on it. So if you use username and pass, maybe at first they won't know who did that, but you can always correlate it back to the time. So it's better to just have your username password in there so you are verified on what you're doing. And the same with microthermal. You can go into the deep back end of it, and I can find out and look at what anything that has been changed. And I noticed that in the microthermal when I started using it about 15 years ago, is that I always had my own username and login versus with the E2 where it was just a username and password. One of the things that I really believe to be successful with controllers in supermarket is understand the basics of refrigeration. It doesn't matter the controller that's on that system, because they all are doing the same thing. The language is a little bit different, but they're all doing the same thing. And the first thing that I hear on the slide is say, understand the basics of refrigeration. When you understand the basics of refrigeration, you can start to understand how a controller is manipulating a system. For example, staging compressor, so the suction group of a system as compressor turns on and turns off. As the capacity starts to increase, we need, and the load increase, we need more compressors to turn on to take down that load to try to maintain and satisfy all those walk-in box and all those cases. And understanding and just listening to a system can help you understand how to look through that controller. What are your thoughts on looking in and out of controller when you're going to a service call, Andrew?
I think it's a huge benefit if you're trying to diagnose a problem. If you go on that E2 and pull up a graph and see the trend, and all of a sudden that trend is different for a moment, or maybe for a long time, then you could go back to that time and what happened here. I mean, to go through the graphs on any of them is going to help you succeed and be successful in a service call, and it's going to jump you that much further ahead. Instead of 30 minutes trying to figure out, now you could whittle it down to 15 minutes or 5 minutes just getting onto the computer. So understanding what you're looking at could be a huge game changer in your service skills.
Yeah.
But the one thing with the on any electronic, it needs to read the correct information. So if you're on there and it says, let's say produce case is running at 38 degrees, but you go down there and they're losing product, or because it's too cold, but the sensor's reading 38 degrees, well, then it's the computer is just doing what it's told. So it's very important those inputs on that board are exactly reading what it's supposed to be. So you have to verify that.
I love that. I love that because I've been hearing and seeing more and more people trying to troubleshoot just from the controller. So they're up playing on the microthermal, the E2, Danfoss, and they're trying to fix the problem that is more of a mechanical or a electrical issue that you can't fix that way. You have to go out and take a temperature probe that reads accurately. So you get your temperature probe, you put it in ice water, make sure it reads 32 or 0, and then you go and verify that temperature probe. I think that is key. And what you said there is that if you don't verify it, you're going to get yourself into potentially more trouble.
Yeah, the controllers is only as good as the information it's receiving. If it's not reading the good information, it's going to give you a bad output per se, or it's going to tell it to do something when it shouldn't be doing. But it's only as good as whatever the outputs are saying.
Yeah. And this is something that I learned from the control experts. So when I was working at Copeland and going through all their E2 trainings and E3 trainings so many times, and then going out to the field with manufacturers and the field startup reps, and then talking with the control manufacturers. So if it was from Microthermal, if it was the control guy, and just a lot of people just ripping on the control manufacturer. Oh, Danfoss is terrible, or oh, Corel's terrible, or oh, E2's terrible. Whatever it is, it doesn't matter because everyone has their own preference because they're used to using that. But at the end of the day, I hear the exact same thing as what you just said from any controller expert. The controller information is only as good as the input information from where it's getting. Pressure transducers, temperature probes, humidistats, whatever that information is reading, that information on those graphs or on those sensors are only that good. Another thing that I've noticed too is improperly set up set points. And that's where it could cause a lot of issues. Have you ever noticed that where the temperature set maybe too low, maybe defrost termination set too high, or maybe the deadband's too close? Have you ever came across any of that before, Andrew?
Yeah, when out of a defrost is taken too high, it's set for a temperature too high, and it's a hot gas defrost, and it actually would cause the other cases to get warm too, because as hot gas goes through a coil and the coil is cold, it has ice on it, we actually condense back into a liquid. And then as we go through, so the pipe coming back, I guess, is going to be all liquid feeding the other line. Well, after time, that ice melts. Now we still got that discharge temperature going in, and it's still a vapor. And then that vapor is still a vapor time it gets out. So now when it goes back to the liquid header, we're feeding vapor throughout the entire cases, and that's going to cause that.
Yeah.
So so in that example, because it was set too high, that means it's saying that, hey, there's still ice on the coil, and we're going to keep going in defrost, which is actually hurting the rest of the cases and system because of it.
Yeah, and I totally agree with that. The next tip that we have on there is knowing where to find a manual. And there's no excuse today not being able to find a manual and read through the manual. Um, Microthermal, E2, Danfoss, Carell, RDM. The list goes on the manuals and how easy it is to find them today. I know I had someone reach out and said, "Oh, can you help me out with a multi-flex board and how it works?" Honestly. And then I asked, "Did you check the manual?" "Oh, I didn't know there was a manual. Couldn't find a manual." Well, did you look? Because it doesn't take too hard to find. There's a whole like 78 or 100-page manual on the multi-flex board for the CPC or the Copeland controllers. And the same thing with microtherm. You ask me, "Oh, I need to," if someone says, "I don't really know how the 700 series works." There is dozens of manuals in the microthermal literature that you can just go and read. It doesn't take too long. I was actually in there reading today um, some information on it, and it only takes a few minutes. And if you spend a few minutes of your time each day diving into these, understanding how to, say, change a board point. If a board point burns out, what do you do? How do you do that? All of a sudden, your pressure transducer is not reading anymore. So one test would be put it on a different point. Have you ever had to do that before, Andrew? Change board points or relay points because they fail?
Yes, unfortunately, it does happen, and it could be a real pain, especially if you don't know how to do it. So that's really one of the basics things you should probably learn is how to change a board point, because that could be a quick, hour call turned into 7, 8 hour calls. So now you're trying to pull up the manual, trying to figure out how to change that set point when it's one of the ones that you should already know,
Yeah.
or at least get into a manual and know where to find it in the manual. You should at least know that, because it does happen, and it will save you. It'll save you hours.
Yeah. Our good friend Noah Walker saying manuals are your best friend. 100% Noah, because this is exactly what you need to do, because you can't always remember everything, but they all work the same. It doesn't matter what anyone says. All the controllers are doing the same things. They're taking some inputs, shooting out some outputs, switching some relays, opening and closing things, and that's exactly what they all do the same thing. They just have a little bit of different language. Some have more features than the others. The more money you pay, maybe you get extra features and licenses. So, but these are the things that you need to know. Get into those manuals. I think I got another here to be successful on controllers is understanding basic controller navigation. What are your thoughts on that, Andrew?
Yeah, understanding the basics of how to navigate your controller is going to save you too. Um, it's hard because all of them does it different. So I'm doing it over and over again. It's going to work. So if you're on a job working on even a self-contained or whatever, and you get the self-contained working, go up to the machine room, take 15 minutes. It's going to help you. And don't change anything. Just scroll through it and try to find, set points and try to find different cases out there, just to dive a little deeper into it, because that might help you in the next service call.
Yeah, and we have the technology, such good technology today. I'm going to give you all a tip right now, and if you take this tip and use it and you implement it over the next 2 or 3 different controllers you work on, is going to be a game changer for you. And what is this tip? Guess what you have in your hand, you carry around with you all the time? You have a cell phone. Okay, you have a cell phone. So you go up to a controller, you take a picture of it, or you can set up your controller and record it. Press a button, log in. Okay, go to the first menu. Look at scroll down so you can read everything. Take a picture or record it. Go to the next one. Do the same thing. Take a picture of it. Anything you don't know, you have it in a picture or record, and then you circle it. I don't know what this means. I don't know what this differential means. And go through it. Go to the suction group. Go to the condensers groups. Go find all that stuff. Go to the hot gas a bypass valve, whatever it is, three-way valve. You can go in and look at all this different stuff, get into the trend graphs. And then you have all this data on your phone. And then afterwards, when you're not at work, take a look at it. Oh, I was going through this. I took these pictures of all the condenser grouping or the advanced suction group, whatever it is. And you go through each one and just learn it. And then when you don't know something, that's when you throw a question up on Facebook into the supermarket group, or you ask somebody at your company, what does this really mean? I don't really understand what that means. Ask the question. Or you can just go and do a research, a Google search in the manual. That will totally help. We have the technology to help you grow a lot quicker. And I really think you can do that. So if you don't understand it, take a quick snapshot. You take a bunch of trend graphs, take a snapshot. Are these the ones that I should be looking at when I'm looking for issues with an evaporator? And it could be your pressure transducer, your temperature probe, your EEV, percentage opening. There's lots of different things, but I think that is important to do. What are your thoughts of using technology to help grow your controller knowledge, Andrew?
Oh, it makes service calls, could be making service calls a breeze. Because you could really go in and figure out if your case superheat is wrong just by a graph.
Yeah.
You pull up and you look at it, and you got a couple degrees off on one case, let's say, and you go in and you graph it out, and you can see the trend is normal. Then all of a sudden, it gets a little longer. It takes a little longer to pull down that case, and then a little longer it takes down. So you'll see, and what could that be? Probably the filter in the TXV is starting to plug up, and it's causing it to take longer and longer and longer to pull down that case.
Yeah.
So, and that I didn't even have to bust out any tools to check superheat, throw it in defrost or nothing. I already have a set plan where I need to go just by looking at it. Also, going back to the manuals, if you guys do print them out and keep it at the store, because if it's, I'm sure there's also more technicians that will, need it. Because any manual that I get, I always put it in an envelope or something that's inside the machine room, so someone could grab that manual and pull it out, whatever it may be.
And lots of people, people steal them or they take them. There's never a logbook. Nobody takes paper anymore. Nobody wants to take the manual. They got it on their phone anyway. Just leave it there, right? Do not take. Use your phone. A good friend Jonathan here put the manuals in a Google Drive. So that's what you can do. Leave the manuals there, have a Google Drive for your company, and it can just go in and all the manuals are there for that store. Easy little things that can do. I got another one here for to be successful, how to override properly. What are your thoughts on using override, Andrew?
Be very cautious, because if you turn something on that shouldn't be on, you force it on, you could cause more damage to the system. Or forcing it off, you could cause more damage too, depending on the application. If it's a three-way valve per se, and you valve it on, well, then it's only using one side of the condenser.
Yeah.
So now you're tripping out on high head, and hopefully you got your mechanical safeties to trip. So it's very, very important to know what you're doing before you do it. So proceed with caution, I would say.
Yeah,
but sometimes it's so necessary to save you.
Yeah. And that's why I put it in there properly, because it's so important to understand it. Because I've done it multiple times, put something into a manual defrost to help out before going to defrost the case and trying to get it started. But if you put it in override and you leave it in override and then you forget to take it out of override, and then you leave the store and they go unload the case, that they'll be calling you back because they're like, the case is not pulling down. What is going on here? Right. So here's another one from John. Set it up on a timer if you need it temporarily. Don't want to forget to turn it off 100%. But another one is that if you ever, just say for an example, you turn on liquid injection, override liquid injection, and you leave that on. Now you're just feeding the compressor a bunch of liquid the whole time, and then you're going to smash it out. So that's why Andrew says proceed with caution. Last one is, and you already talked about it, to be successful, I think the biggest and the number one is reading trend graphs. If you can read trend graphs properly, you can troubleshoot a system from anywhere as long as it has the proper data to read. And now with CO2 systems, we know there's temperature and pressure probes everywhere. What are a couple of tips for reading trend graphs, Andrew?
My biggest tip is understanding what is good. So we get called out all the time because there's an issue. We got product that's going to spoil or whatever. So we're always looking at bad stuff. But do you know what good stuff is? You know what a good trend looks like? So my biggest thing is take the time and understand what a good trend looks like. As soon as you know what you're supposed to have, you could go to any controller, look up the graph, and like, man, there's something weird right here. It shouldn't take me this long to defrost, or it shouldn't take me this long to pull down a case. You know, so knowing what is good is going to help you really succeed there.
Yeah. And this is an example we got on the screen for those that are watching right now is a trend graph for a CO2 system. So depending on what you want to really look at will depend on what you want up there. This one here is for the high pressure valve. So we got the outside air temperature, we got the discharge temperature, we got the outlet drop leg temperature, we got the fan, is the fan running? So this here is all for the gas cooler. And so you take a look at that and you can see how it's kind of hunting. You're going from 900 psi in the gas cooler discharge down to 600, up to 1,000, down to 700. So it's been going like that for days and days and weeks. System's still running, you're maintaining temperature, but you're not running efficiently, and you start running into issues. And you can see the technicians went in there and fine tune it. This is something that you can do, and you can read from trend graphs. They fine tune it, changed a few set points to test it out, and then now you can see how they're like a straight line. They're running at that 700 psi. So these are the things that you need to take the time on. Does this stuff happen overnight? No. But there's all these controllers. I got on the YouTube channel, head to the Refrigeration Mentor YouTube channel. We got how to read Corel trend graphs, how to read RDM trend graphs, how to read E3 trend graphs, even microthermal trend graphs, just like this one. So take the time to learn. But you have to put the work in. And I see it time and time again. We're not spending enough time outside of work hours to get this knowledge in there. The ones that are here tonight putting the work in at 9 o'clock Eastern at night, 5 Pacific, coming to learn a little bit, you're putting the work in. But this is what you got to talk about with the apprentices coming up. This is what you got to talk about the guys that have been doing for 15 years and think they don't need to learn anymore. You got to put the work in, just like Andrew's doing, just like I'm doing, and just like you guys are doing. But it does take time, and there's always people out there that want to help you. Just remember that. There may be people at your company that don't want to help you, but there are manufacturers that want to help you inside those organizations. I know because I talk to a lot of them. There are lots of them in those organizations that don't want to help. Those are the people you're not looking for. But you know what? If you be curious and you come up with great questions for these control manufacturers, they want to learn it too, because sometimes they don't have all the answers either. Some of the people that are supporting the controllers, they might have only been doing it for a couple of years, just like some of you might be only doing supermarket refrigeration for a couple of years. And so what you need to have is a little bit of patience, be a little curious, and take some time to read these trend graphs, because you can make graphs look just like this one if you spend some time on it. Any questions on that, Andrew?
No. The spending your own time learning this stuff is really going to excel your career. And I tell everybody that I work with, all my apprentices, 15 minutes a day. Give me 15 extra minutes studying something that you don't know. One thing a day, one thing a week. You'll know that much more in a year. That extra amount of time that you put in yourself, you're going to be that much better. I can guarantee it.
Yeah. And this is just the start of it. I really appreciate you taking the time to come and watch tonight. I do have a full-on supermarket course for those who haven't taken it, because I see quite a few people who have taken my supermarket course, but I do have one coming up. If this is something that's interesting to you, something interested to some of the people you work with, starting this Friday. Like, if you want to make a difference in what you do, as you got to get into these programs and learn a little bit more. Sometimes it's outside of work, sometimes it's during work, sometimes it's taking that extra step to grow your knowledge, because you got to put the work in. You put the work in now, it's going to pay off later. Just like Andrew has been putting the work in for years and years. And he was a trainer at a technical college, and he went back into the field and he's crushing it out there because he put the work in those extra hours. And I know you can as well. Spend the time to invest in yourself, because it's only going to make you better. I'm going to throw this in the chat if anybody wants to send it to anybody in their team, to their service manager, because this is what we do. We build content for contractors and technicians. And we'll take any questions from anyone, because we are 1 minute over right now for those who are here live on this session. And anyone who's listening on the podcast, put some comments in the show notes. Put some comments. This is how we get better. This is how we learn. This is how Andrew wants to keep coming back and share his extensive knowledge with you.
Yeah, one thing I would say about just learning controls is it really is going to be, you're going to need to take the time. It doesn't happen overnight, trust me. I wish it did. I wish I had that capability, but I do not. And each one is its own identity. So it's not all different. The basics are still there, but how going through it and understanding how it works is it just takes time. And that's why I say when you're on the job and everything's working fine, that's when you want to go up there and kind of go through it all, because then you know what it's supposed to be doing. I'm a big, huge fan of knowing what it should be doing, and then then when you arrive on site and it's not doing what it's supposed to do, like, okay, man, that's where I'm going. It's not turning on. Why? It should be turning on. Defrost, So knowing the order of operation and understanding it and knowing when it's running right is going to make you really just help you out there in the field running service calls.
Yeah, I totally agree, because temperature probes on all of them are all the same. There may be a different variation, different reaction times, but a 10K sensor, 10K 1, 2, or 3 might have different reaction times, but they're all 10K at a certain temperature. So you got to get that resistance chart. Pressure transducers, they do all the same thing. They're reading a pressure on a resistance or on a milliamp scale, whatever the scales are. You just got to go in and understand where's that curve of that and check that out. These things are easy to find online. Just go into the manufacturer and look up pressure transducer, or PT1000 for Danfoss, or NTC for Emerson, or Copeland. All this thing is learnable, and just like Andrew learned all this stuff, I learned this stuff. It's learnable. Spend the time, grow your knowledge. I want to thank you for taking the time. Andrew, any final thoughts?
Other than what I already said, no. I mean, really just that 15 minutes a day. One piece of component out there that you don't. Take a picture of it. Next time you get home, spend that extra 15 minutes out in your van or whatever you need to do. But that is really going to help you out there. And I can't not stress that enough.
Love it. Andrew, thank you so much for taking the time to do this. Thank all of you for taking the time to come and listen. Once again, please share this with people who want to learn and grow their knowledge. We'll see you at the next Refrigeration Mentor training. Awesome, everyone. Thanks.
Thank you.